Our next topic is all about Lesson 2, Energy. Most essential learning competency for this lesson is to identify and explain the factors that affect potential and kinetic energy. Before we tackle the two types of energy, let us go back to the previous concept of the word energy. In science, when we say energy, it is defined as the ability to do work. Like work, it is also a scalar quantity. Another one is a system that possesses energy has the capability to do work on another. And energy is expressed in joules or ergs. So there are also different forms of energy. We have mechanical, heat, light, and chemical. So as you can see in the encircled word, we are going to focus on mechanical energy. There are two types of mechanical energy. We have potential energy and kinetic energy. Let us define potential energy first. Potential energy is the energy that's stored in a body or at rest. Remember that, because the meaning of kinetic energy is the energy possessed by a body because of its motion. So clearly, they are different. There are also two types of potential energy. We have the gravitational potential energy and the elastic potential energy. The encircled words are the focus of our topic. Now, let us further define potential energy. So aside from it is energy at rest, potential energy is the energy of an object in position and a stored energy of a non-moving object. Therefore, if an object is non-moving, it has a stored energy called potential energy. And also, potential energy changes based on its position. So if an object is at a higher position, therefore it has higher potential or greater potential energy. If an object is at the lower position, therefore it has lower or least potential energy. So we have here examples of potential and kinetic energy. So basically this is a comparison. Okay? Next is kinetic energy. So we have already defined potential energy. Now let's move with kinetic. So kinetic energy is the energy of a body in motion. So if an object is moving, it has kinetic energy. It is often called release energy when the mass of the object is overcome by the energy that sets it to motion. The faster the body moves, the greater its kinetic energy is. Okay, so if an object is moving fast compared to an object that is moving slowly, therefore, the one that is moving faster has the greater kinetic energy in it. Understood? Next, can you think of some situations where there is kinetic energy? So here are some examples of kinetic energy. Alright, let's proceed. What is the equation for solving potential energy? So potential energy is expressed by the equation PE equals mgh. So what do these letters mean? First, we have the m, that means mass of the object. G is the magnitude of the acceleration due to gravity. And h is equal to height. So therefore, PE is equal to mass of the object multiplied by the gravity or the acceleration due to gravity and the height. Alright? Based on the equation given, The factors that affects potential energy are mass, height, and acceleration due to gravity. Now, as you can see, acceleration due to gravity is equal to 9.8 meter per second squared. So this value is constant. What is the unit for mass? We have in kilograms, and for height, it is in meters. The unit for potential energy is joule, just like in work. Understood? Okay, let's proceed. Let us try to solve problems involving potential energy. So, let us have this problem. As you can see, the given are already highlighted for you to easily spot it. Problem 1 is, if the mass of the loaded cart is 3 kg and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart at the height of the seat top? So let us have the solution. So we are using the format GRESA for calculating the problem. The given is M or mass is 3 kg, right? Based on the problem. And the height is 0.45 meters. What is the required or what are we going to find in this problem? The potential energy or the PE. And again, what is the equation for PE? It is PE equals mgh. So remember that G, just like what I have said a while ago, is equal to 9.8 meter per second squared. So, for the solution or for the S, it is PE equals 3.0 kilogram times 9.8 meter per second squared, and the height, which is 0.45 meters. So as you can see, the operation that we need to do is multiplication. So we're just going to multiply all of these three, and the answer will be, alright, 13.23 joules. Okay, so now, how about the second problem? Class, it is not always potential energy that is being solved. Sometimes, the other factors are required in some problems, just like this one. So let us try to solve problems involving height. So a box has a mass of 5.8 kilograms. The box is lifted from the garage floor and placed on a shelf. If the box gains 145 joules of potential energy, how high is the shelf? So the question is how high. Therefore, we are finding for height.
Alright, so let us solve the problem now. Given is mass equals 5.8 kilogram and the potential energy given also is 145 joules. So what is the required for this problem? Correct, it is height. So now as you can see at the right side of the screen, we have here a triangle method. So this triangle method includes the variables on the problem, or on the formula rather. So we have PE at the top, and then at the bottom we have mass, the gravity, and the height. So since we are getting for the formula for height, we're going to derive the formula, and what we're going to get is H equals PE over mg, or height equals PE divided by mass times gravity. Okay, so now let us have the solution. So as you can see here, we just substitute the values: 145 joules for PE, and then the value of mass, which is 5.8 kilogram, and also the 9.8 meter per second squared as the acceleration due to gravity. So first is we have to multiply the 5.8 and 9.8 before performing the division. So if we are going to multiply it, then we will have the answer as 56.84. Alright, that is correct. And then, after getting the product, alright, so we need now to divide 145 joule to 56.84. Okay, so just divide it and then we will get the answer. The answer is A equals 2.55 meters.
So let us have the last problem for potential energy. A man climbs onto a wall that is 3.6 meter high and gains 2,268 joules of potential energy. What is the mass of the man? So we are finding the mass. Solution will be, okay, first given our height equals 3.6 meters according to the problem, and the PE is equal to 2,268 joules. So of course, the required is mass. Again, we have here a triangle method. A while ago, we are finding for height. In this one, we are finding for mass or M, which is encircled. Therefore, to derive the formula, we're going to divide PE to GH. So M equals PE over GH. Okay? So now let's substitute the given. So the given for PE, 2268 joules, is at the top, and at the bottom is 9.8 meter per second squared times 3.6 meter. So again, just like what we did on the second problem, you first multiply the 9.8 to 3.6 and then get the answer. After getting the answer, take note of it and then divide 2,268 joules over the answer from this multiplication. And so, the answer will be correct. That is 64.28571,429, or simply 64.29 kilograms. Alright, so a while ago, we calculated for potential energy. Like potential energy, kinetic energy can also be calculated using the equation Ke, or kinetic energy, equals 1/2 mv squared. Now, what do we mean by this? M is the mass of the object in the given problem and v is the velocity. So the 2, which is the exponent here, you should square the given velocity before getting the final answer. So the unit for Ke is joules also. Okay, remember that. Potential energy and kinetic energy and work have the same unit. Okay, next. Now, let's calculate kinetic energy. First problem. Determine the kinetic energy of a 1,000 kilogram roller coaster car that is moving with a speed of 20.0 meter per second. So as you can see, just like what I have done a while ago in the problem, I highlighted the given for us to easily spot it. Okay, remember the given, class? Okay, let us try. For the given, we have mass equals 1,000 kilogram, and for the velocity, it is 20.0 meter per second. Required, of course, is we are finding for kinetic energy. Equation. So, of course, our formula for getting kinetic energy is 1/2 mv squared. Solution. So, let us have this. First is substitute all the given. Ke equals 1/2 times 1,000 kilogram for mass and 20.0 meter per second for velocity. So you are going to square it. So for the next step is, once you have squared the 20.0 meter per second squared, you will notice that it will now become 400. Alright? Now, let us multiply all of them. But, as you can see, where did I get the 0.5 here? So, what I did is, the 1 half, you are going to divide it. So, 1 divided by 2, now you will get the answer 0.5. So that you will not have any fraction in your solution. It will now become a decimal. Understood? Again, where did I get this 0.5? I divided 1 over 2 so that there will be no fraction in the solution. Okay? Now, let us multiply all of them to get the final answer. So, KE equals 0.5 and then multiply by 1000 kilogram and then again multiply by 400 meter per second squared. So, the answer will be correct. That is 200,000 joules. Do we have the same answer in your calculator? If that's so, correct. You are correct. Okay? So, let's proceed. How about in calculating problem, we encounter the mass or we are going to find the mass. So, the problem is a tennis ball is traveling at 50 meter per second and has a kinetic energy of 75 joules. Calculate the mass of the tennis ball. So, remember the given. Okay? Okay, so let us solve the problem. The given in the problem are KE equals 75 joules and the velocity is equal to 50 meter per second. And then again, what is the required? Correct, that is mass. So we need to find the equation for this. Before revealing the equation, I have here a triangle. So as you can see in the triangle, we divided it into 3. At the top is we have the KE. At the bottom, we have 1/2 m and b squared. Okay, so we need to derive this formula because we are finding for the mass. So we get the equation 1/2 m equals KE over v squared. But we need to remove the 1/2 beside the m. So the final equation is m equals 2KE over v squared. Okay? So, remember the equation. Okay? Next. So, for the solution, let us have m equals 2 and then substitute the value of KE which is 75 joule over the value of velocity which is 50 ms. Then, you're going to square it. Okay? So, m equals 150 joule and then over 2,500 ms squared. Okay? So, where did you get this to? So, yung 150 po, we get that in multiplying 2 and 75. The 2,500, we got it from squaring the 50 meter per second. Okay? So, what will be the answer? So, we got the answer 6 times 10 raised to negative 3 or 0.006 kilogram. Okay, so the answer in the problem is the mass 0.006 kilogram. Alright? Did you understood? Okay, thank you. The solution. So again, the given are KE equals 40 joules, M equals 6.0 kilogram or the mass. Then the required of course is the velocity. Equation. So again, let us have here the triangle method. So as you can see, this is the same as a while ago. Now we have the derived formula. Okay, so since we are finding for V, so here it is. V squared equals KE over 1 half M. Okay, now to remove this 2 exponent of V, we are going to use a square root. Okay, so now here is the final formula for getting the velocity. So V equals square root of 2ke over m. So aside from we remove the exponent of the 2, here is we also remove the 1 half. Okay, and then the m is the one left at the bottom. Okay, again, the formula for getting velocity is square root of 2ke over m. Okay, next. So, solution. Substitute the given. So, V equals the square root of 2 times 40 joules over 6.0 kilogram. So, first, you're going to multiply 2 and the 40 joule before dividing to 6.0 kilogram. Okay, so after multiplying, we have V equals square root of 80 joules over 6.0 kilograms. And now, after dividing, so you will divide 80 to 6 now, and the answer will be V equals square root of 13.333. But again, it's not final because we need to get the square root of 13.33333. So the answer or the final answer is velocity equals 3.651483717 or simply 3.65 meter per second. Alright, so did you understand how to solve these problems? I hope you understand. And now, it's time for you to answer your module applying what you have learned in this video. Okay? So, apply what you have learned in computation for potential energy and kinetic energy. So, see you on Thursday and have a good day, everyone. Bye!